Area and volume revision part 2. This one we're going to start by looking at a circle. Alright, with a circle, the key properties of a circle you need to know with area and circumference is the radius is a line that joins from the centre of the circle to the outside. The diameter would be a line that goes all the way across through the centre of the circle. Alright, and the link with them two is the radius is half the diameter. There's two things you're asked to find regarding a circle. They could either ask you to do circumference or they could ask you to do area. So if they ask you to do circumference, all right, to find the circumference, it's circumference is pi times diameter, pi times diameter, pi times diameter. Circumference is pi times diameter. The area is pi r squared. Okay, so the area is pi r squared. To work out the pi button, you can either use pi as 3.14 or normally it's behind the times 10 to the x button or the exp. So then you have to press shift and exp to get that up. Okay, so that is circles. From circles now, we're going to move away. Before I move away, actually, I'm going to just remind you that area is always measured in centimetres squared. Circumference or meters squared. Circumference or is measured in centimeters or meters. Now we're going to look at three-dimensional shapes. And with three-dimensional shapes, we're going to have a quick look at volume. All right? To find the volume of a shape, it depends if it's a prism or not. A prism is a shape that's got the same thickness all the way through. If I'm finding the volume of a prism, to find the volume of a prism, you need to find the area of a cross-section and multiply by the length going back. Volume is always measured in cube now because it's three dimensions. So it's centimetres cubed or meters cubed. 1 centimetre cubed is 1 milliliter and is 1,000 milliliters in a litre. All right, they're the key facts you need to know. I'm going to start by looking at the triangular prism. A triangular prism has a triangle on the side and it's the same thickness all the way through. It's a bit like a Toblerone bar, okay? So a triangular prism is like a Toblerone bar. If I'm finding the area of this cross-section, the shape on the side is a triangle. So to find the area of this cross-section, it's the area of the triangle, which we did earlier, which is base times height divided by 2. And then you multiply, because it's a prism, you multiply by the length going back. So they multiply by the length going back. And that's how you find the volume of a triangular prism. All right, so it's the area of the cross-section, which is a triangle, and you multiply by the length going back. The next shape I'm going to look at are two that are got exactly the same formula. And it's a cube or a cuboid. The difference between a cube and a cuboid, a cube is a three-dimensional shape where all the lengths are the same. All right, so it's a bit like a dice. A cuboid is more rectangular, like a box, like a cardboard box. So they look similar, except the cuboid is a stretched out version of a cube. To find the volume of a cube or cuboid, all right, we normally just use one formula. All right, we normally use the formula length times width times height. Or you can say it's the area of the, so with this one you can either say it's length times width times height, because it's three dimensions. The three dimensions you're looking at are across, upwards, and then because it's the same thickness all the way back is that way. Or you can say it's area of a rectangle or square, which is the same formula, multiplied by the three-dimensional length again, if you would rather look at it as a prism. And as we done earlier, the area of a rectangle is length times width or base times height, and then you multiply by the three-dimensional length going back. All right, so that's how you would find the volume of a cube or cuboid. The next one I'm going to quickly go through is called a trapezoid. And a trapezoid is a trapezium on the side. And we've just done the formula for a trapezium in the first video. All right, the shape on the side is a trapezium, and then it's got the same thickness all the way through. All right, So to find the area of the trapezium on the side, it's half the sum of the parallel sides times the height between them. That is how we find the area of a trapezium. So this one is area of a trapezium. All right, and the area of the trapezium is half the sum of the parallel sides times the height between them. And then you've got to multiply by the length going back. So when you multiply them by the length going back, it's this going back. You know from earlier that that's A add B, and this is the height. Some people prefer to do the trapezium as A add B divided by 2 multiplied by the height going back. And then you multiply by the length going back. And that's how you find the volume of a trapezoid. From a trapezoid, I'm going to now move on to our final shape as a prism. And our final shape as a prism is called a cylinder. A cylinder, all right, is a circle on the side. And it's a three-dimensional circle, a three-dimensional shape with a circle on the side. And on the side here, you've got a circle. So to find the volume of a cylinder, like the others, it's the area of cross-section, which is the area of a circle. Once you've got the area of a circle, you multiply by the three-dimensional length going back. So in terms of this one here, you've got a cross-sectional area of a circle. So area of a circle. All right, and if you remember from earlier, circumference is pi times diameter, pi times diameter, pi times diameter, circumference is pi times diameter, the area is pi r squared. So it's pi r squared multiplied by the length going back. So it's pi r squared times by the length going back. All right, so all of them 4 shapes, the triangular prism, the cube or cuboid, the trapezoid, the cylinder, are all area of cross-section multiplied by the length going back. The difficulty with volume is you don't always have the same thickness. It's not always prisms. So some of the shapes you need to know have not always got the same thickness all the way through the shape. So what I'm going to go on to now is a cone. A cone is like a traffic cone, a bag of chips. You can get a cone of chips, okay? And to find the cone, it's a circle on the bottom, all right, with a radius r. And then you also need to know the perpendicular height going up. Without showing you now how we derive the formula, the volume of a cone, which you should know already, the volume of a cone is 1/3 times the base area, which is a circle. So it's 1/3 times the area of the circle multiplied by the height going straight up. So it's 1/3 times pi r squared times the height going up. And that's how you find the volume of a cone. All right, so that is a cone. There are 2 other shapes that you require, you need to know. All right, the next shape, all right, is a sphere. All right, a sphere is like a 3D ball, imagine a ball with no divots, a perfectly smooth ball, like one you would throw for your dog. All right, and to find a sphere, it's a 3-dimensional circle, so it's quite hard to imagine. All right, and the volume of a sphere is 4/3 times pi times the radius cubed. All right, so it's 4/3 times pi times the radius cubed. And the very last shape that you need to know with volume is a square-based pyramid. So we're going to have a look at a pyramid. All right, and to find the volume of a pyramid, you are doing, all right, you've got a square at the bottom, and then what you have then, like the ancient pyramids, is it comes up and it looks like this. So to find the volume of the pyramid is very similar to the cone in the fact, all right, the volume of the pyramid is 1/3 again times the base area, which this time is going to be a square times the height. So if you're looking at the square and you want to call your square a length times width, or length times length, it's a third times the area of a square is length times width times the height. But you know, because it's a square, the length and the width would always be the same. Alright, and that's everything you need to know on area and volume. Volume, as I said, was measured in centimetres cubed.